So our next presentation will be Clinton Work from TELUS, talking a little bit about their experience in deploying IPv6 on their network, lessons learned, and how we got there. So welcome, Clinton. Forward. Reverse.
Hi. So for people that don't know me, I'm Clinton Work with the TELUS Network Operations team. Matthew Wilder from our tech strategy team actually put this presentation together and submitted it to NANOG. Unfortunately, he couldn't be here, so I've taken over the presentation on his behalf, but I've been involved with our IPv6 program for the past couple of years. So what am I going to talk today about? A few key questions that we had to decide about our IPv6 deployment at TELUS. What did we learn from our deployment and we can share with other people? How did we do our IPv6 address planning? What are some of the big picture realities about deploying V6 for other ISPs and TELUS as well? And then now we get to sit back after all of our hard work and watch V6 scale on our network. And then finally, we'll see if you guys have any questions. The key questions that we answered about, or we considered about our V6 deployment when we started almost 3 years ago. Why deploy V6? Who needs to be involved in a V6 deployment plan? What solutions will you employ to get V6 out there? Where will you deploy V6 in your network? You may have multiple networks like we do. You have consumer customers, business customers, as well as wireless. When will you deploy V6 to your customers? And finally, how do you make sure that you can scale your deployment to all your customers? Okay, so the first question, why deploy V6? So, probably everyone's aware, Aaron's out of V4 address space. Doesn't mean all ISPs are out, but V6 will solve that problem in that you'll be able to get as much address space as you need for your customers for the foreseeable future. One of the other reasons to deploy V6, your customers are asking for it. And, we certainly had a number of customers that were really keen on getting V6 access through TELUS. Today, a lot of our customer traffic may be NATed with home gateways and such. And by deploying V6, you can provide an end-to-end path. We also have customers that do a lot of peer-to-peer applications. And again, V6 will provide a clear end-to-end path that doesn't have to go through NAT and deal with any of those potential problems. The last reason is that if people or ISPs don't make progress on deploying V6, then maybe eventually there'll be some government regulation. So if we deploy it ahead of the government having to get involved, and in Canada we have the CRTC, then it demonstrates that self-governance or governance is actually working properly. Okay, so who needs to be involved in your V6 deployment plan? We involved, the best and the brightest from different areas of our business to make sure we were successful. We had a large number of people from our network engineering, network operations team, security, and very important to have your people from our systems and application primes that support our customers and deploy services to our customers. The other thing we did is make IPv6 a top corporate priority in order to secure resources to make it successful. And also focus on long-term service alignment around IPv6 rather than just a small, quick and dirty project to get it done for one area of the network. Also, be inclusive. IPv6 is not a one-time effort. You're going to have to, every project that comes up, a new service, you're going to have to consider it, and it'll be a new way of doing business. Consider the continuum of IPv4 through IPv6, and we tried to aim for an end state of IPv6 only, just because V6 is not a solution today for V4 exhaust. Consider what is practical by service. What may be very practical for our home internet customers may not always be practical for our wireless services. TELUS offers the following services, and these are kind of what we decided to target for IPv6. So on the consumer wireless side, we are going to target IPv6 only on the handsets, and there are a number of US wireless providers, I think AT&T and Verizon, that have already gone down this route. On the consumer home internet, we're going to go dual stack, and where we run out of V4 address space in the future, we may have to deploy NAT44 for some services. We really don't want to, but just because of the number of peer-to-peer applications that consumer customers use, going V6 only wasn't exactly practical at this point. And then for our business internet customers, we're going to target dual stack. Excuse me. When and where. So immediately 3 years ago, we targeted our peering and transit connections, and we modified our procedures so that whenever we turn up a new peer or we add or modify our transit providers, we made sure that we enabled dual stack IPv6 connectivity. We also targeted early our client-facing DNS servers to make sure that they were dual stacked. And in our case, because we already had a V4 MPLS network, we decided to deploy V6 across our core using 6PE. It made the most sense for us, and we haven't had any major issues with it. We also focused our development on newer networks where the support for V6 was already available. We just had to deploy it. We also focused on areas of our network where, particularly our consumer services, where V4 exhaust was most imminent. We also focused on high growth services and where we have to consider deploying NAT, or we've already, a lot of customers have deployed NAT on their home routers and such. And just learn from our deployments and trying to adapt more broadly in the future. So where and when? In 2012, we modified our peering and transit behavior, and the following graph here shows over the last couple of years the percentage of new peers that we're able to turn up with dual stack connectivity. It's not as high as we'd like it to be, but we've been able to enable all of our transit providers with dual stack connectivity, and our larger peers and CDN connections have all been V6 enabled. How? Take opportunities to get experience with V6 wherever you can. So for TELUS, we've provided internet connectivity to a number of conferences in Vancouver and other places. So we started in Vancouver in 2012, where we sponsored network connectivity for the ARIN conference, the NANOG conference, IETF, and then we gave several more. We actually, from that, we found one issue with our 6PE configuration in one of our routers. Based upon the NANOG meeting, we were able to quickly get fixed. So, having some example traffic and experience with deploying V6 and making sure everything is running properly is very valuable. We had to, develop some robust provisioning processes and support capabilities, develop methods for rapid enablement, and build V6 into the scope of future projects of services we were considering going forward. So this is just a graph from 2012 of the overall traffic that we saw at the IETF meeting, IETF 88 in Vancouver. This here is a graph of the V6 only traffic, so it was about 30%, or sorry, 10% of it. It was surprisingly low, but it seems like the ITF crowd doesn't like to watch much Netflix or YouTube streaming. So, key learnings at TELUS. IPv6 just works at this point for most of our users. We have had very few reports of any troubles. The network, we also found that the network is the easy part. It's layer 8 and above, mainly your systems, that really took all the preparation time and work. In particular, policy management, customer records, and security are far more challenging. We also, it takes some time for people and processes to catch up. Managing dependencies and interlock with other infrastructure projects that you may be going on at the same time. We also invested heavily in communication and training. We created some instructor-led courses for the core IPv6 team members. We also purchased an e-learning course for the broader team members at TELUS. And we also created some company-wide communications so they were aware of our progress with the IPv6 rollout. Take time to develop a strong IP management plan with route summarization, geolocations for different parts of your network, and keep security in mind as well. We also found that the RIPE Atlas and NANOG tools were very useful for verifying that you have IPv6 connectivity to other providers, as well as troubleshooting issues that we had. Particularly, I found NANOG very useful for that because you can have a ping test done all at once from all the NANOG nodes back to your IPv6 host to verify that you have no connectivity issues. Other key learnings around education. Our operational staff need to be ready for IPv6. We have deployed the e-learning course from NEFO 6. The graph below shows the TELUS team members within the first 5 weeks of launch, the number of registrations, the accesses and completions for that course. Challenges that we encountered. On our home gateways, they had to be updated, a software upgrade in all of our home gateways that we provide to customers to enable IPv6 support well ahead of time. To avoid a flood of DHCP version 6 requests and subsequent radius, we needed to sequence the enablement on our network as part of our rollout plan. So we first enable IPv6 in our policy management system. We have to go to all of our access devices that those customers are connected to and enable the DHCP option 18. And then finally, we go and enable the DHCP version 6 scopes on our aggregation routers. And in this way, we were able to prevent a large number of failed DHCP version 6 requests that resulted in radius requests to our authentication systems. Eventually, we'll have to target some CGN and NAT44 rollout to our less sophisticated services where people maybe only focus on web browsing and other simple services. We've done a trial with CGN and NAT44, and we did find out that it broke, as expected, some port-seeking applications like desktop sharing, where they're trying to make a connection back in to their devices. The challenges we had on the wireless side, the different device OSs have different strategies. Android devices clearly support XLAT. Apple's strategy with V6 is that for V6 only is with iOS 9, they're going to recertify all the apps so that they'll work on a V6 only network. We also found an issue with some LTE chipsets in a lot of phones where if the customer is close to the US border and they start to roam on a US network versus our Canadian one, that they'll lose network connectivity for several minutes. So we're working with a chipset vendor to try and fix that before we can do a more extensive IPv6 rollout for Canadian wireless customers. And we also had a few issues on certain handsets with MTU sizes where, ironically, the PMTU packets were too big and they were getting dropped by the phones. So PMTU wasn't working at all on IPv6. So we had to make some changes to the TCP stacks on the phones and their configuration to avoid that. Okay, so our IPv6 addressing plan. We'd recommend, doing your v6 allocations on the nibble boundary, so by increments of /4 to exploit the hex notation, just makes things easier. We also used regional blocks for summarization of routes for geolocation. So in a lot of cases, we broke it down in Canada by province, and then in some cases by major centers, we allocated different IPv6 blocks for those to help us with aggregation in the future. We also found that, with v6, little address space goes a long way. So a single /64 can be used for all of your regional point-to-point links. I know some service providers prefer to use a /64 for every point-to-point, but we didn't have an issue. We interfaced with other service providers. We used a /127 or 126. If you want to go with a /64, that's fine. We haven't had any issues with the /127 approach. You can also allocate, and we did, a /64 for all of our router loopbacks addresses so that they're all in one contained address range. And we also dedicated a /48 to all of our backbone infrastructure to keep it in a separate address space from any of our customer address space. And so you can implement infrastructure ACLs to filter out any of that traffic at your edge of your network. Service addressing. So what we've gone with is for business internet customers, we will assign a /48 to each of those customers statically. For consumer customers, we will allocate a /56 via DHCP prefix delegation. And then each of our consumer customers on the wireless side will get, each handset will get its own /64. Don't take a chance with the ULA address space. Hopefully no one will. And just enjoy the abundance of IPv6 address space that you have available. A few big picture realities that we considered. Not all service providers will exhaust their existing v4 address space in the next 3 years. So that may be a consideration for you. IPv6 will offer the most reliable end-to-end path between endpoints as NAT 6 or NAT 444 or carrier grade NAT has to be deployed by those ISPs that are exhausting. Everybody has a good reason, content providers, ISPs, to adopt v6 for the benefit of their users. We expect that IPv6 traffic will surpass 50% of the global internet in the next 3 years. We'll see if we're right or not. It takes time for ISPs to go from the inception of the program to actually deploying. It took us approximately 3 years to get from the point of starting our plans, getting all the systems complete, and actually being able to roll it out to our customers. So the sooner you get going, the better. Now we get to sit back and watch it scale. We've completed the v6 enablement of our consumer internet customers in Quebec. We're currently working through our Alberta customers, and then we'll move on to BC. We are hoping that by the end of the year, we'll finish our consumer internet rollout in Canada. This is a graph. We started our large-scale rollout in June, and TELUS has gone from below 1% IPv6 enabled to, I think the latest graphs I looked at here were around 8% of our users can now get IPv6. We also have a graph here from the Cisco Labs that pulls the Google data and then allows you to graph it over a selectable period of time. And the Canadian IPv6 enablement has gone from 0.5% in June to now looking at the graph, it's over 2%. So we're hoping as we finish our rollout that the Canadian IPv6 usage will increase to 5% or a little bit higher than that. And that's all I had. Are there any questions?
Middle first. You're the first to arrive.
Oh, hey there. My name is Bobby Flame. I'm with the United States government. I'm one of the co-chairs of the IPv6 task force. And in trying to get our own U.S. government rolled out to be IPv6 100%, some of the problems we had were with vendors and providers and even some cloud service providers. How did you deal with that challenge? Because I know that sometimes when you go to certain people, they're not as enabling or as positive as you are insofar as getting to IPv6. So I was just wondering how you may have dealt with some of those challenges.
Sorry, so the question was around how we dealt with vendors and...
Yes, so in other words, when you had to go to vendors or other, when you needed other services, how did you deal with that? Because when we have gone to procure certain things or services, equipment, we've run into some people who have like, no, well, it's capable but not enabled, it's been tested, not tested. So how did you, number one, did you have any challenges? And number two, how did you deal with them? Does that make sense?
We definitely did have some challenges. One of our vendors, we use a lot of equipment from both Alcatel-Lucent as well as Juniper. Juniper had always good support for IPv6. We didn't really have any challenges there. Alcatel-Lucent has very good support for v6 as well. However, the policy management system that we were using from Alcatel-Lucent at the time didn't have any support for IPv6. So as part of our planning, we kind of focused on newer areas of our network where we already knew the equipment supported v6. The policy management issue was somewhat of a surprise, and it took us a long time. We had to basically go and upgrade that entire policy management system so it had support for v6, and then we could start our rollout. I think the network piece generally from our experience has been pretty easy because most of the vendors, especially the newer equipment, has good support for v6. It's more on the system side that can take a lot of work. It's also, I think I've found more in the data center side, it's been a challenge in some cases because people have older firewall or security products that aren't as easy to upgrade. But it seems like a lot of the network vendors have taken v6 very seriously and their support is well tested.
Okay, let's go to that side, number one.
Hi, Rob Seastrom. I work for Time Warner Cable, and I have a learn from our fail tale. But first I want to see a show of hands. Who here has deployed a single stack IPv6 product environment at a reasonable scale? Any hands? I'm not surprised. Did you find broken stuff in your network? We found broken stuff all over our network that had been there for a couple of years. And the reason is that it's easy to screw up something when you're not used to looking at it. And for a lot of the folks who are deploying or initially putting IPv6 configs out there, you get it wrong. It's your first try. Why didn't the phone ring? Real easy, happy eyeballs. Who was hiding it from us. So we went to roll out something that didn't have a plan B built in, and all of a sudden people are calling and saying, well, it's failing one time in N. What's with this? v6 mostly works, but every so often something's just like the SYN goes out and the ACK doesn't come back. And we found things like ECMP, which was mostly working, and as long as you got lucky and the 5-tuple hashed onto the right thing, and ping hashed onto the right bundle, ping hashed onto a working bundle, but you know, every so often you get a TCP session that didn't. So ping isn't enough. Test your stuff, strobe across multiple sets of ports, multiple sets of protocols, do some live traffic testing as part of your rollout. Your applications people will thank you later.
Okay, thanks.
Yeah, I would agree. I mean, we did a lot of lab testing by our tech strategy team to make sure it worked. And we also did a friendly trial with a lot of TELUS employees to make sure that the V6 services worked properly on the network before we started a large-scale rollout.
Oh yeah, to be clear, this was the friendly trial where we found it. It would have been a lot worse if it wasn't.
Thanks. I think the back.
Hi, Philip Matthews, Alcatel-Lucent. A little bit strange here. I hope you guys can hear me better than I can. I'm wondering about your IPv6 only wireless deployment. How are you handling older devices?
Could you hear it?
Yeah, how are we handling IPv6 only for wireless? So, yeah, older devices would be V4 only. It's newer devices that we've certified to work with V6 only. There's extensive testing that's done with every handset before the configuration and the new firmware is pushed, before those devices are turned V6 only. So we know well ahead of time that all the features on that phone will work. Older devices that aren't getting firmware updates anymore, they're going to have to stay V4. But devices that support IPv6 only, we have NAT64 gateways deployed with DNS 6.4 for if those phones need to get V4 only sites, then they'll go through the NAT64 gateways. But a lot of content now from Google, Netflix, Facebook, other companies is already dual stacked, and a lot of the traffic will be V6 only from the start.
So they're going to get separate contexts? Is that the idea, the old and new?
Yeah, we have separate PDP contexts or APNs for the V6 only. I mean, one of our options is we could have gone dual stack, but it kind of defeats the purpose. We'd really like to get to the end state of V6 only, so that's been kind of our goal.
Thank you.
Okay, question, mic 3. Yeah.
Yes, hi, Andrei Hemenkov with Athena Health. Maybe trivial question for service providers, not so trivial for not so much service providers. How did you go about automating the provisioning of the address space? Slicing, dicing? I can't imagine you did that by hand.
How did you automate the provisioning, the slicing of the address space? Was it all by hand?
Well, I mean, we have a system that supports both our V4 and V6 address space, but we did, it's an inventory system that supports both V4 and V6, and we kind of split it up by regions based upon our customer base. We expected the IPv6 usage to grow, and then for each of our aggregation routers, we allocated a certain amount of address space based upon how many customers we expected to be on each of those routers. I think that's what your question was.
Also, I guess, basically about reprovisioning, which I imagine you did all the links on your network. I don't know, what was the scale of that rollout? Did you keep the core IPv4 and just roll IPv6 into